welcome back to school for many of you. This is second week of August right now, and I think for many of you, you've been back in school at least a week, sometimes maybe even 2 weeks. Here in Michigan, in my school district, we don't go back to school until after Labor Day. And in fact, since my school is under construction, I'm not able to get into my classroom at all. So I'm not able to show you anything that's happening in my classroom yet. But I have conducted 6 APSIs this summer as an AP Precalculus consultant. So I've had a great opportunity to work with a lot of teachers all over the country. I want to thank my teacher friends in Minnesota for turning me on to the Building Thinking Classrooms in Mathematics book by Peter Liljedahl. I've been reading that. I'm going to incorporate some things in my classroom and talk to you about those things in a later video after I can get in my classroom. But one of the things that I think would be prudent to discuss right now in the beginning of the year in AP Precalculus is the whole issue of concavity. So if you do a control find on the word concave in the course and exam description, or CED, you'll see that that word concave comes up 19 times. So what I'd like to do really is just give you a quick demo of thinking about what's the relationship between increasing and decreasing functions and the whole rate of change with increasing and decreasing functions to help you explain it to your students in a non-calculus way. So let me just get my computer going here and I'll make a couple of diagrams and we'll talk about it. All right, so the first thing that you definitely need to know is how do you find the AP Precalculus course and exam description? And if you just type in AP Precalculus CED, that stands for course and exam description. This is a public document. AP Precalculus course and exam description can be found here. So we're going to click on this button, and there you go. There's the course and exam description. So as I said, if you do Control F and type in the word concave, you see 19 times. The first time the word concave is mentioned is in topic 1.1, change in tandem. It doesn't get any earlier than that. So you can see under Learning Objective 1.1b in the Essential Knowledge B3, we talk about the graph. Well, first of all, we're talking earlier in this topic, we're talking about intervals of increasing and decreasing for the function. And then we talk about when the graph of a function is concave up, that's on intervals in which the rate of change is increasing. And the graph of the function is concave down on intervals when the rate of change is decreasing. So let's talk about what this means. I made a couple of diagrams for us. So looking at the functions on the top, h of x and g of x, you probably can tell by looking at these functions that they're both concave down. But let's kind of back it up for a minute and just talk about increasing and decreasing. So how do we determine, I guess, technically whether a function is increasing or decreasing? A function is increasing. Actually, I want to use purple here. The function is increasing when, as the input values go up, the output values go up. So in our AP Precalculus course, we want to get away from referring to things as X and Y and start referring to them more as inputs and outputs. And I got to put an axis back in there. There we go. So a function is increasing when, as the inputs increase, so do the outputs. So our h of x function is an increasing function. Now, if you look over at the g of x function, as the inputs increase, the outputs decrease. So as the x's increase, the y's decrease, but we want to get away from referring to x's and y's and talk about inputs and outputs. So g of x, by that definition, is a decreasing function. Now we know, because we're all math teachers watching this probably, that these functions are both concave down, h of x and g of x. But let's talk about the rate of change as the inputs increase and in relation to the outputs, and see if there's a pattern with these two functions, which are both concave down. So what I'm going to draw right now is a couple of slopes of a tangent line that might be intersecting with h of x in just a few spots here. Well, so I'm drawing little tangent lines, but what I want to talk about is the slope. Now, just like we want to get away from the language of x's and y's and talk about inputs and outputs, we want to get away from the language of talking of slopes and try to get into the habit of discussing a rate of change as synonymous with what you may have called a slope before. So let's just kind of guesstimate some slopes here. So this first slope, I'm just going to say that looks like maybe a rise of 2 or run of 1. So let's say the slope is 2. For this next slope, I'm just going to estimate that the slope is 1. For this next slope, I'm going to say, well, how about if we say maybe it goes up 2 and over 3? And again, I'm just kind of approximating here. And for this last slope, why don't we say it has a rise of 1 and a run of 3? Okay, so slope and rate of change are synonymous. So if you're thinking about what is happening to the rate of change as the inputs increase, or as you're looking at the graph of h of x from left to right, first we have a rate of change of 2, and then a rate of change of 1, and then a rate of change of 2/3, and then a rate of change of 1/3. What does it look like is happening? Are these rates of change increasing or decreasing? Well, if we're going from 2 to 1 to 2/3 to 1/3, or 1/3, we would say that the rate of change is decreasing. So even though h of x is increasing, the rate of change as we look at h of x from left to right, the rate of change is decreasing. Okay, now let's look over at g of x. I'm going to do the same thing. I'm just going to draw some little mini tangent lines here. And I'm just going to kind of randomly say what the slope could be. Now, these are all negative slopes, right? So this first one at the top, let's say that slope could be, let's say like negative 1/3. And the next one down, maybe that's negative 1. And maybe we'll call this one negative 2, and we'll call this one negative 3. So again, I'm just kind of randomly guesstimating the slope of those little tangent lines. As we look from left to right, we go from a rate of change of negative 1/3 to negative 1 to negative 2 to negative 3. So this function g of x, which is decreasing, has a rate of change as you're looking at the function from left to right, also a rate of change that is decreasing. So that's the idea here, is that a function could be increasing or decreasing, like h of x is increasing and g of x is decreasing. But the idea here is that anytime a function is concave down, the rate of change will be decreasing as you're looking at the function from left to right. Now let's look at a couple of other examples here. So we've got an increasing function, j of x. So j of x is an increasing function, just like h of x was. And k of x is a decreasing function, just like g of x was. Okay, but we can tell because we just know that both of these functions are concave up. We can tell by our eyes, but how can we justify this? So let's go back to drawing some little tangent lines. So on j of x, I'm just going to draw a couple of tangent lines. And again, let's just kind of estimate the slopes of those tangent lines. And remember, slope and rate of change are synonymous. So for this first slope, let's say maybe we'll just say positive 1. The next one, that looks like maybe the rise might be a little steeper. So let's say maybe 2. Maybe for this one, we'll say 3. And for this one, we'll say 4. Positive slopes here, right? So j of x is an increasing function. When we look at the slopes of the tangents, as we look across j of x from left to right, in other words, as we look at the rate of change goes from 1 to 2 to 3 to 4. This rate of change is increasing. Okay, well, j of x was increasing because as its inputs increased, its outputs increased. J of x is concave up because its rate of change is increasing. Now let's look over at k of x. I'll just draw a couple of tangent lines again. And let's just, again, estimate some slopes. So these are negative slopes now. Let's say this one is -2, maybe -1, -1/2, -1/3. So look at those rates of change from left to right, and what do we see? -2, -1, -1/2, -1/3. Even though k of x is decreasing, the rate of change is increasing as you look across k of x from left to right. And in fact, that is how we are defining concave up, intervals of concave up. Whenever the function has a rate of change that's increasing, the function is concave up. So one last example here, just to kind of tie it all together. If you're thinking about a sinusoidal function, already color-coded it. The purple intervals are where f of x is increasing, and the orange intervals are where f of x is decreasing. Now, I can tell because I know, I guess, because I have more knowledge than I need for this AP Precalculus course, I know already, and I'm sure you do too, where this function is concave down. So I'm just going to highlight in yellow intervals where this function is concave down. And let me highlight in blue intervals where f of x is concave up. So I'm just going to draw a couple of tangent lines and ask you to, again, think about slope. So, let me keep going. We'll do a couple over here. Okay, so this first one, let's say maybe that's a slope of 2. And the second one, let's say that's a slope of maybe 1/2. And let's keep going. Maybe over here, this could be a slope of -1, and this could be a slope of -2. Okay, well, in this interval, which we can tell with our eyes is concave down, let's now compare the rate of change in this interval of concavity. We go from 2 to 1/2 to -1/2 to -2. Even though f of x is increasing and decreasing on this interval of concave down, as you look from left to right, the rate of change is always decreasing. And the same will be true in the next period. Okay, now let's look at our interval where we know it's concave up, but let's just validify that by looking at the rates of change. So I'll draw a couple of tangent lines again. Okay, so on this interval of concave up, as we look at the rates of change, we're going from -4 to -3 to 1 to 3. The rate of change is increasing on the interval that I have highlighted in light blue. So even though the function itself is decreasing and then increasing, the concavity in the concave up interval it's concave up because the rate of change is increasing on that interval. I hope that helps. Now that you've seen these examples, I want to just go back and show you the language of the CED just to validify what we talked about. The graph of a function is concave up on intervals in which the rate of change is increasing. The graph of a function is concave down on intervals in which the rate of change is decreasing. So I hope this helps, and I hope that your school year gets off to a great start. Don't forget to subscribe to my channel on YouTube, and we'll talk again soon.